And we don't want to end with a fizzle, so we have Eli with us. Eli Lipsitz is coming in from Cambridge, Massachusetts. I pestered him endlessly about his Game Bub project until he agreed to launch it on Crowd Supply, which I'm glad he did. He's going to talk about his adventures in creating it and changing it, and can I say about soldered? Is that? Yeah, okay. And you're working with Soldered Electronics to actually bring it to market. Soldered is also a creator at Crowd Supply and now a sponsor, and now they make stuff for other people too. So Eli, take it away.
Awesome. All right, well, thank you for coming out here. This is my first time at Teardown. And thanks for being here at the end of the day. So today I'm going to be talking to you about a project that I've been working on for the past 3 years or so. I'll talk kind of about how I first got interested in emulation and how that led to the most complex engineering project I've ever taken on solo. And I have a lot to talk about in about 20-25 minutes, so let's get started. So this project is Game Bub. It's right here. It's an FPGA-based emulation handheld. It plays Game Boy, Game Boy Color, and Game Boy Advance games. It's compatible with original hardware, cartridges, link cables. You can also load ROMs from an SD card, which is great for playing homebrew like Apotris here. It's fully open source, hardware, software, and gateware. And I built it from scratch for however you wanted to find that. For me, it was being able to point to anything on the PCB, being able to point to any of the line of the code, and being able to understand it and knowing what it does and being able to explain it. Of course, I still use a bunch of open source libraries for things. So a lot of people here are probably familiar with FPGAs or FPGA emulation, but in case you're not, an FPGA is a field programmable gate array. It's essentially a chip full of generic logic gates, memory, and interconnects. It's a huge oversimplification, but it can be reprogrammed to implement a new digital circuit. So a software emulator that a lot of people will probably be familiar with, just like a program you download that's a Game Boy Advance emulator, is going to be a computer program that simulates the original hardware. An FPGA emulator is going to be a digital circuit that ideally behaves the same as the original hardware. So there is a distinction here, and I'll talk more more later in the talk about how FPGA emulators compare to software emulators. But first, I'll talk about how I got into this project. So I grew up in the early 2000s, and my older brother had a Game Boy Advance, which meant that I had a Game Boy Advance. And I played Game Boy Advance games, Nintendo 64, GameCube, that sort of thing. And so I definitely have some lingering nostalgia for that era of gaming. And later, I kept using emulators to continue enjoying those games. And it really kind of felt like magic that I could just play a Game Boy Advance game on my computer. And therefore, if emulators are magic, the people who create them are wizards. Which is not entirely true, as I learned. So in the summer of 2017, I was doing an internship where I essentially ran out of work to do. And I had just taken a computer architecture class, and I really liked it. I was interested in low-level stuff. I had nothing to do, and I thought, hey, why don't I try writing an emulator? So I picked the NES, Nintendo Entertainment System, because it was kind of the simplest real system that I cared about, an actual thing that plays actual games that I was familiar with, but it was still fairly simple. And turns out it actually wasn't that hard. It's super well documented, really well documented system. There's a lot of great documentation. The NES Dev Wiki is great. And it was just a really, really cool project. So unfortunately, school started again before I finished implementing everything, but it was just kind of like a really satisfying project. So here's a screenshot of some early broken graphical output. I think broken emulators are more interesting than working emulators, sort of Anna Karenina principle here. So later, at the end of 2021, after I graduated and working a regular job in industry, my super, super cool project that I was working on at work got very suddenly canceled. And they essentially just told us to take like indefinite time off while we figure out what we're doing next. This was 2021, not 2023. And so this was around November. They said, all right, we'll come back after Thanksgiving. We'll figure out what we're doing. Then after Thanksgiving, they were like, all right, we'll come back after the holidays. We'll figure out what we're doing next. And at that point, I was like, okay, I kind of want something to do here. And I got the emulation itch, and I decided to write a Game Boy Advance emulator for a system that I had a more personal connection with and was also more advanced than what I had done before. In my opinion, the Game Boy Advance is like the perfect system. It's complex enough to have like a lot of interesting things to work on, but it's still perfectly manageable if you have some prior experience in emulation. It's like a relatively modern design, kind of more familiar than the NES, and it's really well documented. It's definitely a step up in complexity, but there's also a lot of great games. So it took about a month to do the bulk of the work, and being able to have Metroid Fusion, for example, playing for the first time was just an incredible feeling. This game that I played and really liked as a kid, seeing it running on my own emulator. So in the beginning of the next year, I was still employed and still had nothing to do. And I thought, all right, maybe I'll make my emulator more accurate. I thought maybe I'll do a more complex system like SNES. But then I was thinking, like, I don't actually know when this ends. Am I just going to keep leaving the trail of unfinished emulators as I go on to the newer, greater thing? And I thought maybe about doing something completely different. So when I wrote other emulators, there was kind of some behaviors, like how things were laid out or some edge cases or something that hinted at the underlying hardware. And I was interested in exploring this further. And so I decided to approach emulation from the perspective of a hardware designer. So I was vaguely familiar with the existence of FPGAs, had no experience, had never like used an FPGA emulator or anything like that. And I thought, why not write a Game Boy FPGA emulator? It's simple-ish. It's on par with NES. It's one of the things that people recommend you get started with. It was new to me as an emulation project. And I thought, like, okay, how hard could it really be? As it turns out, this was like an extremely ambitious first FPGA project, but I didn't know any better. So I got an FPGA development board, the Pink Z2, which is a really great board, inexpensive, has a lot of stuff in it. Taught myself Verilog, and I just kind of went for it. So I set up a simulation environment and started just implementing the CPU from what I remembered about how CPUs work. And I wrote tests, and it was coming along. And then I started working on graphics, and I kind of lost steam. So I just started a new job, and I no longer had infinite free time. I don't want to blame Verilog here. Like, it's not good for me to blame my tools, but Verilog is like actually a terrible, terrible language. Like, it is so bad. Everything uses Verilog or VHDL because it's like there's just too much history behind it. But it's like an old language. Wasn't designed for what we use it for now. There's a syntax that maps terribly to the underlying concepts it's trying to express, and there's so many footguns. It's pretty bad. But this is not a Verilog rant talk. So I kind of shelved the project, and I didn't even touch the FPGA. So fast forward a year later, my project at work was canceled again. You're probably noticing a trend here. I picked up the FPGA Game Boy project again. And this time, I did things a little bit differently. I started using Chisel. So Chisel is a modern HDL. It's built on top of Scala, and it compiles down to Verilog. You need to compile down to Verilog because all the vendor tooling uses Verilog, but it's really a lot better. So it was just kind of like a breath of fresh air. You express the hardware concepts directly. There's no weird inference about like you use something this way, so you're using a register, or you use something this way, so now it's a latch and your thing is going to be completely broken. You just say exactly what you want. And it's built on top of the Scala type system, which is like a blessing and a curse, I guess. So there's parameterization. It's really easy to compose components. And it just made things a lot nicer. So I converted the CPU to Chisel. It was nice, and I just had the motivation to keep going. This is kind of the best part of an emulation project where you're just knocking out features and implementing graphics and sound and input and all that stuff and actually kind of seeing it come together. And I was really enjoying it. And for lack of a better phrase, I kind of felt like a connection to the hardware. Like I understood why things were the way they were, which is great. And all that was done in simulation. So I wanted to actually run it on a real FPGA. So I made an adapter board to add a cartridge slot, Game Boy cartridge slot, and a link port to the Pink Z2. Shout out to KiCad for making it really simple to do this. And it was actually surprisingly cheap to get the boards manufactured, so that's cool too. And I think this plays here. Yeah, that's the first output of running. It turns out it's easier to just like tile than do the math to crop. So that's why you see like 6 Metroids. Looking back on this, I'm actually like shocked that any of this worked at all. There are like so many bugs and issues there that I didn't know about that all stemmed from a very, very incomplete understanding of how FPGAs work. Just like so many problems in there that I later had to fix. I sort of was under this impression that FPGAs are just a magic box where you put Verilog in and you get behavior out, and they are not like that at all. So I later added support for emulating cartridges, so you could load a ROM file into memory. The Pink Z2 has memory, it has some DRAM, but it's connected in a way that isn't super convenient to use, and it's optimized for long linear bursts rather than random accesses, so it's like how a CPU uses it to fill up a cache and then you access it. And that's kind of a problem because each Game Boy cartridge access is just a random access that has to complete in under a microsecond. So most of the time it works, and then maybe the controller refreshes at the wrong time and now you don't have your memory, and then bad stuff happens like this. So I then had to have a thing where I can halt the system if the memory is too slow, and wait for the memory access to come back. But then on the Game Boy Color, which can run twice as fast, this is sometimes too slow, so I had to add caching and it ended up being like a whole mess. So I wrapped up the project by adding Game Boy Color support and link cable support, and I started to think about what I was going to do next. I really was enjoying working on this project, and I wanted to keep working on it. So the next logical step would be Game Boy Advance. I don't think the Pink Z2 would have been able to do the Game Boy Advance just because of that memory architecture. So it was just barely sufficient for Game Boy. I thought, okay, maybe I'll just make a custom PCB for this FPGA. I can put the memory I want on it. I can have a cartridge slot built in. Then I thought, well, okay, it's kind of weird. The Game Boy Advance are handheld devices. It's kind of weird to be using an Xbox controller on a monitor to play these games that were handheld games. And if I was going to be making a custom PCB anyway, I might as well do more. So I started making a list of kind of all the things that I might want to do for this project. And I was starting to realize that this could take me like literally years to do. And it could become a never-ending project. But I also thought maybe that's actually a good thing. So I realized it could kind of be my perfect project. A project tailored for me, designed for unlimited expansion opportunities, the ability to say, hey, I feel like working on Game Bub for a few days, let me go implement a new feature, without having the overhead of having to start up a new project. And also with the ability to say, this is like a thing that works and I don't want to work on it anymore, and still being able to point to it and have it be an actual thing. So I over-spec'd it for my original requirements. I have a more powerful FPGA, Wi-Fi and Bluetooth that I still don't use for anything, but maybe. Expansion header on the top so that I could add some additional hardware like IR blaster or solar sensor that some games use. And it's essentially a playground for my own experimentation. And I kind of sketched up a high-level block diagram. This is not the final block diagram. A few things changed, but all the core ideas are there. And it started to look like it was maybe beyond my level of expertise. I have no real electrical engineering experience. And the problem here is that FPGAs are just really, really complicated chips, much more complicated than like a simple microcontroller. There are literally dozens of data sheets about every aspect of how you use one of these chips, from like the different packages you can get it in, to how you configure it, to design rules for BGA components, to power specifications and clocking, and how the I/O works, and the I/O voltage levels, and the layout guides and design checklists. And there was also a 4 megabyte Excel spreadsheet for estimating power consumption, which also only runs on Excel running on Windows, which is really annoying. And I kind of got over this because there are a bunch of open source reference designs, or at least open schematic designs for development boards. And so you can kind of look at it and have some of the confidence that you're not doing it entirely wrong. It took about a month to design the schematic. A few times I think I really thought about abandoning the project. There were too many sheets in the schematic, and there were too many components. Like audio is a whole rabbit hole. But I powered through. I was just kind of really afraid of going through all this effort, spending all the money, and then I could just get a bunch of useless boards because I did something wrong. The other issue is I had no mechanical design or CAD experience. That's okay, because there are YouTube tutorials. And nobody actually told me no, which is great. I didn't really tell anyone I was doing this, so there wasn't anyone to be like, that's stupid, you should do something smaller. So I made this animation. I had KiCad set up to take a snapshot every time I saved, and I'm really proud of it, so I just have to show it to you all. This is me laying out everything, and annoyingly it stops, so it skips the part where it actually shows you the completed version, but it's there. I built the first prototype. I had the boards sent to JLC PCB, which I'm sure a lot of people use. Gave them some money, and a few weeks later I had the finished boards in hand. I did some initial bring up, plugged the boards in, and I pressed the power button, and the MCU actually turned on, which meant that my power wasn't, like I'd successfully designed, sort of designed. I successfully laid out a switching regulator, which was a big thing for me. I hacked together some initial bring-up code with MicroPython, which was great, just to be able to quickly run some like I2C transactions and see that things were working, and see if I need to do any rework. The FPGA worked. This is video output from the FPGA. I had not yet figured out exactly the right way of sending it, but it kind of works. And I ported over the Game Boy core from the Pink Z2 project. And you can't see in the back, but there is a Pokemon Silver cartridge in there, and it works. So this was a huge milestone. I'm pretty amazed that things basically just worked. There were some minor issues, but nothing that impeded functionality, just kind of increased the power consumption a bit. And probably helped that I was so nervous and like quadruple or quintuple checked all the data sheets before I did anything. I made the mistake of not finalizing the enclosure design before manufacturing the PCB, so I had to design the enclosure around the PCB rather than kind of code design. I built a GUI for it, so I could have more of a finished product to point to, and I used a nice open source embedded Rust GUI library called Slint. It's pretty good. Game Boy Advance, I did that. It actually took months and deserves way more than one slide, but oh well. So here is it running a Game Boy Advance game. And here are some bugs I had. The Kirby's are not supposed to turn into letters, but they did. And I did a second hardware revision. So after about a year or so, I had a list of things I wanted to change. And so after the Game Boy Advance was stable, I got to work on the second revision, designed the enclosure and PCB at the same time. And I kind of expected it to be my final hardware revision, so I went all out and got some custom cover glass and everything, and I think it really makes it look a lot more professional. I also made a dock for video output, and then I was a little overconfident and I messed it up, and then I had to do some rework. Please don't judge my soldering, but that was pretty annoying. And I got this advice once that it's not a finished project until you write about it. So I needed a stopping point. I needed some way of summarizing this stuff. So I wrote up a super long blog post that if you're interested in more of the technical details, you can read. I wrote some documentation for it. I made a trailer video, and I released everything as open source. So as far as I can tell, Game Bub is the first open source FPGA emulation handheld, and it's the first open source Game Boy and Game Boy Advance cores that support cartridges and link ports. There are some closed source FPGA emulators out there. And I had no real intention of manufacturing a bunch of these, so I wanted people to be able to make one and enjoy it and share it. And people have actually already sent me some photos and videos of ones they built, which is super cool. I also benefited a lot from open source projects. Like I mentioned, KiCad, FreeCAD, Chisel, Verilator, all sorts of things. And it didn't really feel right to not have it be open source. Because I also benefited from so much open source emulation research and documentation. So there's a lot of documentation out there and a lot of really accurate emulators that you learn from. And the emulation development community is really great, an awesome community and super supportive. So I wanted to contribute back. Don't have a whole lot of time left, but I do want to rant for a second. I promised I'd talk about FPGA versus software emulation. And there's a lot of hype about FPGAs, and I'm hopefully going to dispel some myths. So FPGAs are really good at precise timing and hardware interaction. They can interface with arbitrary hardware because they can just do things. Say you wanted to run a Game Boy Advance cartridge off of a computer using an emulator on your computer. The Game Boy Advance can do an access every 120 nanoseconds. USB is way slower than that. PCIe is also way slower than that. You just can't do it. FPGAs can have really low latency, really low input latency. They're directly connected to the hardware. They can just read the buttons. They can just output to a display. And there's nothing to add slow abstraction layers. And some aspects of this system are easier to model in hardware, usually the interactions of a bunch of separate components together. And I put this note here that cycle-accurate timing kind of comes for free. Cycle-accurate timing is everything happens precisely during the cycle it's supposed to, which is important for some systems. The cycle-accurate timing that comes for free is kind of like saying that the free meal you get with a $1,000 business class ticket is free. So FPGAs are so much harder to program for, in my opinion. Completely different programming model. Some things are just basically impossible to do. Like some emulators have like save states or rewind, and it's really easy. It's just kind of some mem copies in software, and it's much, much harder than that on an FPGA. They're less powerful. You can't really do like a GameCube emulator on an FPGA, but it doesn't matter because you don't need to, because the later the system, the more powerful it is, the less the low-level hardware details matter. FPGAs are way more expensive, so the price of downloading MGBA is $0. The cost to buy an FPGA is more than $0, and so it's just a lot less accessible. And unfortunately, there's a lot of really misleading or false marketing claims because FPGA emulation devices are a product that someone can sell you, and so they want to sell you it and convince you you need to get one. So one of the claims that you get is that it's not emulation. I think this is just blatantly false. If it's not the original system, it's an emulator. They're not perfect replicas. Maybe it would be different if Nintendo took the original layouts and designs for the Game Boy Advance and made it go on an FPGA, but they didn't and they won't, so it's not really worth talking about here. FPGAs are not inherently accurate, I should know, because I wrote a very buggy emulator that I had to improve. They're only as accurate as the program to be exactly the same as the software emulator, and software emulators can and often are more accurate. They can just make certain aspects easier to achieve. And they both rely on reverse engineering, so it's kind of up to the knowledge that the developer has. One claim here is that accuracy is the most important metric. It's basically impossible to achieve, and it doesn't really matter because games don't require perfect accuracy. And it's not the same as compatibility. You can be very accurate on a lot of tests and still not work in certain games because you can't actually achieve perfect accuracy. And there's often claims that FPGAs are kind of the only way to preserve video games, and I think this is just someone trying to sell you something. I don't think a proprietary closed-source FPGA device preserves video game history any more than just the original devices do. Software emulators are significantly more accessible, right? You don't need special hardware. And open research and technical documentation are the actual key to preserving video games. If the documentation is out there, it can never go away. FPGAs can provide some motivation to do some of this, but they don't solve the problem. And it matters because I think it's a little unethical to make false claims to get someone to buy something. And people repeat these false claims as fact. And then you have flame wars, and then you have software emulator developers that are like, well, I don't really want to do this because everyone's just hating on my project. It's really disheartening and infuriating just to be told your work isn't that important because it's not an FPGA. And calling something open doesn't actually make it open, just saying. FPGA emulators are built on the foundations of software emulators and all of the open source research that's out there. So to conclude, you should write an emulator. They're really fun. Start with a system that's simple. NES, Game Boy is good, but preferably something you have some connection to so you can feel the enjoyment when you play a game you played before. You don't have to be a low-level architecture wizard. You can learn as you go. You don't need an FPGA to start. Most of what you're going to be doing is in simulation anyway. It's really slow to put something actually on an FPGA. You're going to need to learn Verilog, unfortunately, and then you should go immediately learn something else like Chisel or Spinal HDL or MeGen or Amaranth, some Scala and Python-based HDLs that are, I think, a lot more pleasant to use. And you can also just kind of make things. So I think this is probably clear to everyone here, but it wasn't to me because I didn't really have hardware experience that you can just make a PCB and you can just do a thing. And you can just learn as you go, which is great. So my write-up got a lot of traction, and a bunch of people reached out asking where they could buy one or if they could collaborate on a commercial project, and none of them really went anywhere, partly because of my limited time and partly because my commitment to keeping Game Bub open source. But one kind of stood out to me, so Josh actually spoke on the phone. Josh from Crowd Supply spoke on the phone with me for a couple hours and convinced me, maybe against my best judgment, to start a Crowd Supply campaign. It was not the original goal of Game Bub. I did not intend to sell anything to anyone, but it's a way to take Game Bub to the next level and get into the hands of people who are interested in it while still keeping everything open source, which I think is really important to me. And I also really want to release a project because after 6 years of work as a professional software engineer, nothing I've worked on has ever actually made it to users. So it's really disappointing. I was hoping to launch the campaign before Teardown, but I still have a few things to finalize. Actually, I'm working on making it horizontal. I think that'll be a little bit more appealing to a lot of people. So thank you. If you want to read a lot more, like way more technical details about this, I have a write-up on my personal website. You can check out Game Bub and see all the source code and everything, criticize it on GitHub. And then you can also check it out on Crowd Supply. Subscribe for updates. It will launch soon, I hope. So, thank you.